Let's get started. Welcome again. Today we will talk about how a left-shifted observability speeds up debugging of complex systems. And very last piece of housekeeping about myself. My name is Vladi and I'm the Director of Community at Multiplayer. I will be your presenter today. And a bit of what we do. Multiplayer helps teams develop and debug distributed systems through full-stack session replays. And as you can imagine, it means that I spend a lot of time deep in observability land, and that's where my knowledge and scars come from. So today, we're going to be talking about how the observability world has been abuzz with discussions of how observability is changing, evolving, and even whether we should be versioning the term observability. And my objective today is to spark some conversations on how observability can be used in many other use cases besides monitoring production for downtime. And in particular, when it can be used to fix bugs faster. So we'll look into how we got here, how it affects developers, and how you can adapt your team's approach to observability. As a starting point, let's take a quick stroll through the history of observability to just understand how it's shifting left. It helps to see how we got here. And as I walk through some key stages, try to spot where your team fits in, and it might even help you frame where you want to go next. Okay, so we're gonna dive deep into it, and I like to think of this as a tale of logs, metrics, and a little bit of drama as well. In the 1990s, with the rise of internet era giants like Yahoo, Amazon, and Google, we saw the emergence of truly large-scale distributed systems. These systems brought new levels of complexity, and with them, a growing need to understand performance, reliability, and failure modes across many interconnected components. So to meet this need, engineers began instrumenting their systems with the core signals that we still rely on today. So think about logs to capture what happened, metrics to quantify system behavior over time, and actually slightly later, distributed traces to follow requests across services. At the time, this was called monitoring, and the focus was on detecting known failures and setting up alerts for when things broke down. As we entered the 2010s, architecture shifted dramatically with the rise of cloud-native systems. So think of microservices, containers, ephemeral infrastructure. These systems brought scale, speed, and a lot more complexity. And at the same time, we see an explosion in the telemetry ecosystem with tools like Prometheus, Grafana, Elasticsearch, Open Tracing, Open Census, which then became Open Telemetry. And engineers started emitting massive volumes of telemetry data. However, while monitoring was incredibly helpful, and still is, we realized that we need something deeper to truly understand the black box that some of these systems had become. And so this is when we started talking about observability as a way to understand systems that's different from monitoring. In 2017, Peter Burgon, a software engineer focused on distributed systems, suggested that observability consists of three pillars: metrics, logs, and traces. And this definition just caught fire and found strong support within the APM tool in the industry, as it coincidentally aligned perfectly with their product offerings. So I want to take a moment to understand a little bit more this version of observability, which is now sometimes called the three pillars observability or observability 1.0. Because in truth, it's not just three pillars. Teams use many different tools and data types, each focused on a slice of telemetry. Think, for example, of APM tools like New Relic and Datadog, Grafana for infrastructure logs, RUM tools like Sentry or PostHog, tracing tools like Jagger, dashboards, SLO trackers, product and marketing analytics. And each one of these tools processes telemetry data in its own unique format. For example, it could be log files, time series databases, columnar databases, even proprietary systems. So as you can see, it's not just three things. And what all of these tools have in common is that they're doing monitoring for known unknowns. So these are anticipated failures, problems you expect to happen someday, but not sure when. So effectively, you're predicting what kind of issues might arise Think of high latency, error rate spikes, and what data you're going to need to diagnose those issues. So that then in advance, you can start collecting metrics, you can set up thresholds for what is considered bad, so you can set up alerts, and you can set up dashboards, visualize this data. And this type of approach is mostly reactive. The tools tell you that a problem exists in production, and based on your predefined questions, it has an answer. And that's why these tools are great at detecting health problems and trend spotting. Another characteristic of these tools is that they have a very specific audience: ops, DevOps, SREs, platform teams. But also one final aspect of them is the cost. There was a recent Gartner webinar discussing the exponential rise in the cost of observability, and they bring as an example a company that had a $50K bill in 2009 with a single vendor. And remember, as we said, most companies have multiple vendors. And they renewed with that single vendor in 2024 for 14 million, which sounds a lot until you think that Coinbase paid Datadog 63 million that 1 year. And there are many reasons why observability costs might increase. Think, for example, the digitization of businesses, right? Organic growth of your business and hence of your data. And as your business grows, so does the complexity of your infrastructure and your application. So it's not unusual to see organizations ingesting hundreds of terabytes of telemetry data daily, and even going up to petabytes of data. And also you have observability tools sprawl, as we said. So you're paying to store the same-ish data in multiple tools and formats. And the more context and detail you want to store about that data, so the higher the cardinality and dimensionality, well, the more you pay. The problem is that you're spending all that money on telemetry data and then struggling to understand how much of this data is actually utilized. So to keep costs down, you maybe try to reduce the tool sprawl, you adjust the cardinality threshold, or you pre-aggregate metrics or sample traces. But this results in losing details that might be useful later, or wasting engineering hours trying to find a balance between having enough detail to understand your system, but not so much that you go bankrupt. So let's go back to our history lesson. During the rise of the 3 pillars of observability, people like Charity Majors, Ben Siegelman, and other industry thought leaders had tried to clarify the difference between observability, telemetry, and monitoring. And the argument is that observability extends beyond traditional monitoring and is about investigating and understanding complex systems. Issues and problems in distributed systems are often nonlinear, difficult to predict, and rarely isolated. So it makes it very hard to anticipate every potential failure or create a dashboard for that. The objective of observability is to empower teams to reveal unknown unknowns, and not just know that there is an issue, but why something is happening and how to prevent it in the future. So in August of last year, Charity Majors, co-founder of Honeycomb, wrote an article which argues that we are undergoing a socio-technical sea change when it comes to observability. And that's why this term should be versioned. Companies are changing how they approach observability, both from a technological standpoint and in how teams behave and work. And so that's why she called it Observability 2.0. So let's look into that. Her main technical argument is that instead of relying on multiple pillars of observability, remember the slide about more than 3 pillars, well, we should unify data into a single source of truth, uniform both in format and storage. And any structured high cardinality event data stored in a single place can serve this purpose, though wide structural logs are particularly well suited for that. And you can derive all other data types, so metrics and traces, from this single source of truth. So in other words, she's saying that you don't need to know all of the questions in advance and then configure your tools to find answers to those questions. Even if you don't know the questions at the right time, you can still find the answers later. And of course, the cost will also depend on your organic growth, the system architecture, but keep in mind that with that single source of truth, you have fewer tools. And especially, you'll save engineering hours because your engineers can now address those unpredictable, unforeseen, unknown unknowns faster. In a distributed system, understanding what went wrong, why, and how requires correlating data across various system layers, which is often time-consuming and prone to human error. And after all, it requires pinpointing specific data points and interactions that might be missed if you have a fire hose of unrelated data to sift through, or if you're drawing conclusions from the aggregate results. Your team isn't just more effective at debugging, they can now be more confident in exploring and understanding the system. And finally, it's no longer just under the remit of DevOps and Ops and platform teams, but it's tools that are used by the entire team throughout the entire software development lifecycle. So here's a fun tidbit from that Gartner webinar that I mentioned earlier. One of the reasons observability costs are climbing is that people actually use it. When they try these type of tools, they rely on them, which honestly makes perfect sense. Because our systems have gotten so complex that the old ways of understanding them just don't cut it anymore. Not long ago, you could sketch your entire system architecture on a whiteboard from memory, and there was a high chance that it'd be pretty accurate. Today, not a chance. And with hundreds of microservices and even more dependencies, nobody's keeping all of that information just in their head. And I do want to mention that not every team leans equally into every single item on this list when they are talking about Observability 2.0 tooling. Some emphasize the single source of truth like charity. Others emphasize more the importance of extending observability to the entire team. Okay, so going back to that history lesson, in December of last year, Hazel Whitley, a senior lead software engineer, proposed another version of Observability 3.0. And her premise is that even when engineers have the tools to ask meaningful questions of their systems, they're still working with the same data that powers other teams. Think, for example, of product analytics, business forecasting, marketing segmentation. So right now, that data is fragmented across tools and teams. But what if it weren't? What if we unified these workflows so that everyone, engineers and non-engineers, could explore system data and act on it? So that's her argument, that the next big culture shift might be bridging the gap between observability and business intelligence. But there is one last twist. In March of this year, Matt Klein, the co-founder of Bitrate, argues that Observability 3.0 is something else, actually. So if you have a single data format and storage location per Observability 2.0, you get deeply detailed telemetry to understand your system. But you still need to send all the data that you might ever need ahead of time, which is still a significant amount of data from a cost perspective and an unnecessary noise. So to keep costs low, you might end up in that vicious cycle of trying to optimize the cost and then spend engineering hours trying to manage sampling. So you end up second guessing the value of every log and field that is emitted, and then you start limiting them and having less visibility into your system. Instead, Matt argues to capture everything locally on the user's device and only send telemetry when a specific error condition or pattern is detected based on smart rules that developers have set. Okay, so that was a lot. We've gone from monitoring to Observability 3.0, and I'm sure there will be more versions, more definitions, and more hot takes along the way. And maybe you recognize where your team fits in. Maybe you saw where you'd like to be. One thing is clear. Underneath all of the versions and the terminology, we are all chasing the same goal. We want to understand our systems better. And the concept of shifting observability left is not new. I can think back a couple of years, 2 or 3 ago, when we started to see the first articles talking about this. And we are still talking about it, maybe using different terminology, but the underlying concept is the same. Shifting left means giving developers more power. And shifting observability left means bringing observability tools into developer workflows earlier. So maybe the word shifting isn't exactly right. Maybe we should be saying extending or expanding, because we are not moving observability from one owner to another, but just expanding the ownership. And I think to explain this a little bit more clearly, it's easier to look at some examples of what it means not to have observability earlier in the software development lifecycle. So what happens when you don't have observability in pre-prod? Well, I'm conscious that larger organizations and regulated industries may invest in observability across environments. Many teams still don't have it in development and staging. And when that's the case, they face three key challenges. So the first one is that they're unable to effectively troubleshoot pre-prod. When something breaks in staging, you're flying blind. Without observability, there is no way to trace requests, inspect service interactions, or debug the failure effectively. So effectively, that means slower feedback loops and longer release cycles. You are unable to spot unexpected behavior before production. So not seeing a failure doesn't mean that everything worked as expected. Without observability, you miss the quiet failures, the unintended side effects, or the inefficient flows, things that may not throw out errors, but still impact user experience or performance once in production. And you're also missing untested edge cases. Most test suites validate expected behavior, not the weird stuff. And so without observability, you can't identify gaps in the test coverage until it's too late. And maybe I don't have to say this, but I'm gonna do it anyway. Fixing issues early in the development lifecycle is far more cost effective than addressing them after a system goes live. According to an IBM study, the cost of fixing an error after the product is released can be many times higher in each subsequent phase. Okay. Another problem is that without visibility into both staging and prod, you can't identify environment drift, differences in config, traffic, infra setup. Observability lets you validate not just the functionality, but consistency across environments. So let me give you an example from one of our users of how environment drift and lack of early visibility can create bugs that pass through all of your tests unnoticed. So this is an issue that happened with an investment bank. The engineering team shipped a new feature for an internal finance tool used by traders. And it allowed them to customize the time intervals for analyzing volatility. And everything looked great in dev, QA, and the regression test. But once it hit production, one trader noticed something weird. The tool showed zero volatility after 12 p.m., even though the market was still open. And the team spent hours debugging. They ruled out an upstream data provider issue, front-end issues, and finally, they realized that there was a mismatch in time zones between prod and non-prod environments caused by the new windowing logic. This new logic was enforced using the user's local time, which showed no errors in dev and staging because all systems were configured according to the developer's local time. Production, however, ran on a different time zone, and the local time enforcement caused volatility to be calculated based on after market close hours. And no alerts were triggered because HTTP responses were still 200s with empty array responses. So this is the perfect example where observability in pre-prod would have identified the drift between environments, but also a great example of having observability 2.0 tools in prod would have allowed you to identify the issues more quickly. For example, a full stack session replay with correlated front-end and back-end data would have captured the user switch to custom intervals, the change in graph behavior after 12 p.m., and the silent failure, leading directly to the time zone logic as the likely culprit. Okay, and that's the perfect segue for me to talk about production environments. Most teams have some form of 3 pillars of observability designed for monitoring known issues, and that's being used by their ops teams. But what happens when you don't have the deeper introspection offered by Observability 2.0 for the entire engineering team? Well, the very first challenge is that you have a harder time finding the root cause. While Observability 1.0 is excellent for monitoring system health and detecting known issues, it's often not detailed enough to support deep developer-led debugging. In systems with many microservices and APIs, root cause analysis requires more context than what sample traces or pre-aggregated metrics typically provide. And it's also an issue of having to correlate data across multiple tools and between the front end and the back end. And the next point is very much related to the first one, but worth mentioning on its own. When observability is only available to ops, SREs, or platform teams, the people writing the code lack direct visibility into how it behaves in production. And this creates a dependency loop. Developers wait on someone else to investigate, interpret, or grant access to telemetry. It slows down root cause analysis, creates communication overhead, and delays fixes overall. So another challenge would be limited support for unknown unknowns. Distributed systems, as we said, don't always fail predictably. When something breaks in an unexpected way, you can think of, for example, misconfigurations, a rare concurrency issue, a flaky downstream dependency, and there's no alert, no signal. It's just a vague symptom that often actually it's your users reporting to you. And the very last challenge that teams may encounter is missed low frequency but high impact events, because sampling and aggregation help manage costs for sure, but they also cut out rare but important events. A bug that affects just the 0.01% of your users might be invisible in pre-aggregated metrics or completely dropped from sampling. But what if that 0.01% is one of your biggest enterprise customers? To catch these rare events, you need fine-grained data that surfaces anomalies in the log tail. So what do we do about it? Well, whether you're troubleshooting quietly failing features in staging or chasing intermittent bugs in production, the common thread is clear. You need better visibility earlier. And that's exactly where OpenTelemetry comes in. OpenTelemetry is underpinning much of the progress in both traditional and emerging observability areas. It's born out of the need to move past fragmented proprietary tooling and to provide a vendor-neutral, open-source common language and toolset to generate and collect logs, metrics, and traces, regardless of your stack. And OpenTelemetry adoption is actually quite widespread across the industry. The last time I checked, I think it was more than 1,000 companies and hundreds of contributors worldwide. But to really get the most value from it, you have to go beyond the defaults and the dashboards. And so that's why I have some tips on how developers can get the most value from observability tools like OpenTelemetry before code reaches production. And I ran these suggestions past our team, who added some scores and comments to them. So I'm just going to share everything today. The first suggestion is to use lightweight local exporters instead of a full observability platform in development. And yes, it's a common suggestion, which is why I got a 2 on the score scale, but it's often overlooked. You can just use OpenTelemetry's SDK to output telemetry data as logs printed to the console. And this is great for debugging locally, no infrastructure or dashboards required. The second tip is to increase sampling to catch more details in lab. Now, this concept is known, but many developers forget to override sampling rates locally. It's a medium effort, high return tweak. Production sampling is usually limited to 10 to 20% of traces. When dev instances are run, however, you can temporarily enable 100% sampling so that you can identify bottlenecks or edge case failures or just important signals. Third tip is to reduce environment drift. Traces can be tagged with environment metadata using attribute key. This informs of trace origin, depth, staging, or prod, and reduces noise. It's a quick win that makes querying comparison across environments much easier. As a fourth tip, you can replay real user traffic in depth. And I know that the engineers know about load testing, but very few actually extract real traces from production and use them to simulate traffic in development. using tools like load testers. So for example, Grafana K6 supports the OpenTelemetry metrics format. And this is a powerful technique to reveal bugs that wouldn't otherwise show up, especially if it's done regularly. Of course, it's to be done with caution since production data can be sensitive. Fifth tip is to use full stack session replays to capture more context during debugging. And while recording sessions is not new, right? You can think of RUM or front-end screen recorders. Tying front-end behavior to back-end traces, logs, and metrics in one timeline is a time saver, and not every tool does that. It removes the guesswork in correlating user actions with system behavior, especially in distributed systems where the front end and back end span many services. Second to last tip is to auto-generate test scripts from your session replays. Most teams manually write test scripts after an incident, and having a tool that turns a real bug into a testable, reproducible script automatically saves hours, and it does help build better regression coverage. And very final tip is to feed your AI ID real debugging sessions. AI IDs like Copilot or Cursor shine when they're generating code, but they struggle with complex debugging because they lack that full stack runtime context. If you want actionable fix suggestions, feed them data from session recordings that correlates front-end with back-end information so that it has user steps, API calls, logs, traces, failure paths. It's actually everything that happened. And since I mentioned the AI, I cannot but spend one slide talking about that. This topic could warrant a webinar on its own, but here's the one point that I want to leave you with. Many engineering leaders are exploring how to integrate AI into their daily workflows or tech strategy. And that's smart. But AI doesn't magically fix bad visibility. You've heard the phrase, right? Garbage in, garbage out. And it applies here too. If your systems are a black box, if your telemetry is sparse, sampled, or missing context, then adding AI won't help. It'll just give you faster guesses with poor inputs. But if you shift observability left, if you invest in rich real-time telemetry and connect it across environments and layers, then AI becomes a powerful amplifier. Okay, so let's wrap it up. Shifting observability left, bringing it into development and pre-prod and not just production, and expanding the team that uses observability tools isn't just about catching bugs early, although it's very much about that too. It's about changing how we build, ship, and support software. It's about understanding system architecture in real time, validating assumptions, and shortening the time between writing code and understanding its impact. Shifting observability left isn't just a technical choice, it's a strategic one. The systems we build today are too complex to fly blind until production, and engineering time is too valuable to be used guessing. Well, thank you so much for listening to me. This is the end of the webinar, but the beginning of the Q&A. Let's see if there are any unanswered questions in our chat. Okay, so it seems that Steph and Tom did a fantastic job already answering all of the questions. Yeah, we'll give you another couple of minutes to see if there's anything else that we can answer for you. As I said, don't be shy. Okay, well, that's it. Thank you again for joining us today. You can try full stack session recordings today at multiplayer.app, and I hope to see you next time.